he's not here, so I'm filling in. But also it's a good fill-in because it's indeed my pleasure to introduce Dr. Shiraz Taib. She is one of our graduates. He graduated in 1975. He got his first degree, the BS, from Nairobi, and he got his master's and PhD here. He has been working on many different companies. I can tell you that I was just mentioning to him that when I finished my PhD, I was asked that I need to meet with him so I can find a job if I wanted to go into the industry. So that will tell you that at the time that I graduated, he was a very well-known expert in the field of pavement. And at that time, he was working not just in the concrete, but also part of the pavement management system. One thing I remember when Shiraz's name comes up is Ilislab. So I'm sure all of you have been working with Ilislab. So this is the guy. So the guy who developed
JSLab is another version of Ilislab.
Okay. So he has been working. That's accurate, right? Yeah. So he worked on that Ilislab, which became, I guess, an icon for the University of Illinois that has been developed in Illinois. And of course, we have the ILIPAVE, so both of them. I think I can talk a lot about Shiraz. I've been working with him on committees. He has been working with us on conferences. So it's not just his technical part, but most importantly, his leadership. One of the things that I can tell you is the Concrete Association or the Concrete Pavement Association conferences have been always successful because of Shiraz's contribution. Actually, whenever we talk about these conferences in the ASCE, let's get Shiraz. I think that will definitely make this conference a success. So Shiraz, I can keep talking and talking, but your commitment to the profession is overwhelmed, and we're very, very pleased that you are one of ours, and you are here to talk to us.
Thank you, Mark.
So please join me to welcome Shiraz.
Good afternoon. It's really good to see Professor Marshall Thompson, and Jeff, Professor Ressler here. We've been dealing with each other for a long, long time on different topics. And I'm really pleased to be here presenting this seminar. Because time is short, I'm just going to go into the presentation itself. So how many, just out of curiosity, how many of you are concrete side versus the asphalt side? How many of you concrete side? He's afraid to raise his hand.
He's hiding behind Jeff.
So maybe I can talk about a lot of things and nobody will pick out any errors except for Jeff. Okay? But anyway, it's good to be here, and hopefully this new, the discussion on this new technology will give you some hope for future work in this area. It's a developing area. So let me start. So I'm going to, this is a new development. Recent development. And this has been in place about 15 years. So we are still developing and refining the technology, but a lot of people are not aware of it. So I'm just going to give you a pretty good overview of all the different aspects of this technology, instead of just focusing on one and going into much more detail with that, So we'll talk about the applications and the systems. When I say PCP, it refers to the precast concrete pavement systems. And then some technical considerations and some design considerations, panel fabrication, and a little bit on performance as time permits. I usually have more material for presentation, and so as I see somebody raising hand saying, stop talking, I'll stop talking, or people start walking out of this room. So let me start. And if you have some questions, clarification, please raise these questions. We won't get into detailed discussion. We can leave it for the end. So basically, the issue that I'm going to be talking about is dealing with our highway systems with a lot of heavy traffic, typically in urban areas. How many of you are from Chicago area? So, or any urban city? Okay. How many of you have gone to Chicago? Okay. Most of you. Okay. So what is one of the concerns if you are driving into Chicago? You worry about traffic. You worry about congestion. Okay. Even on nice days when there's no construction work, there's still congestion. Now add on to it construction work. What happens? 10-mile long backup, okay? Especially if the repair or rehabilitation work is being done during the daytime. So this is the problem. We cannot afford, a lot of our highway system, a large part of our highway system is all aging. A lot of the pavements were constructed during the 60s and 70s during the interstate system. And many of the highway agencies are still using that same old pavement, at least on the concrete side. They have not done major rehabilitation. And now with this heavy traffic in urban areas, it's getting more and more difficult to do our rehabilitation, okay? In Chicago, most of the major highways are carrying about 100 to 200,000 vehicles per day. We can't afford to delay the traffic on this type of systems. In California, almost all major cities have highways with really high volume, okay? So, what we have been doing in the past, so we need a solution for this rehabilitation. We have to upgrade our highway system, basically the pavements. We can't afford to do it the normal way, okay? Especially in the concrete pavement side. So typically, we say we can do short closure, typically nighttime work, and then open to traffic by 5 or 6 in the morning. And we have been using rapid setting concrete, but that has not always performed well. So we are always taking a risk, and we are coming back after few months to few years. So we are basically fixing the fix. Now, if you want to do it correctly with concrete, and this applies more to rehabilitation of concrete pavements, we can get longer service life, like 20 years, 30 years. But we have to have longer closure because we need to cure the concrete for 3 to 7 days or more, and we can't afford to do that, okay? So the solution is short closure and longer service life. And precast pavement, we know will be able to provide that. So we're looking for short closures, typically nighttime closures, but expecting a longer service life, okay? So the definition of precast concrete pavement is a pavement system that is fabricated and assembled off-site. So we are casting the concrete off-site into panels, okay? Panels like this. So if you can assume this is a concrete panel, we are preparing it off-site, curing it off-site. When it's time, we bring it to the site, we place it, we can have traffic on it the next morning, okay? So the system's components require minimal curing time because we are still using some grout and so forth, as I'll discuss later on, for the dowel bars and for under the panel itself. And so, but the curing time is like 2 to 4 hours, still during the nighttime. And we can still manage to open to traffic by 5 or 6 a.m. in the morning, okay? So I'm talking about some applications and the systems now. So this is a recent technology. We have been using it in a production basis since about 2001, okay? And used primarily for rapid repair, rehabilitation of longer lasting pavements or treatments. If you can afford to close, this is slightly more expensive, but the costs are coming down. So if you can afford to close your highway and do conventional repair and rehabilitation, maybe this is not the right candidate. But if you do not have the time, or you cannot afford to do the lane closures during daytime, this is a candidate you have to consider, at least the highway agencies have to consider. Okay, so as I mentioned before, panels are fabricated off-site, transferred to the project site, and installed in a prepared foundation. Only minimal fuel curing time is required, typically nighttime work, short work windows. We basically start closing the lanes at about 8 p.m., and then we are expected to open it to traffic by 5 or 6 a.m., depending on location and so forth. Okay, so we are basically using this for heavily traveled mainline interstate pavements in urban areas, and also for ramps also, where we have a single lane ramp in an urban area, we can't afford to close it, then we would be using this technique. And we are also beginning to use it for intersections, bridge approach slabs, underpasses, bus beds, and so forth. Not much application yet on the airfield side. We have had 1 or 2 projects, but it hasn't progressed much yet. So these are the states where we are actively using this technology. So it's not something that's still experimental or in a development state. So California, Utah, Illinois Tollway, New York, New Jersey, this is their bread and butter rehab technique. When they have a problem on their pavements, especially concrete pavements, or heavy volume asphalt intersections, this is their primary strategy for correcting those issues. The other one, states that are shown in green here, they've already done some demonstration projects, and they're considering production use of this technology. So this is the application, okay? We are doing full depth repair, full slab replacement, or full depth repair, where there's only the problem is only at a joint. Or we would do, this is called intermittent repairs, or just repairs, or we would do continuous repairs. So a single line replacement or a multiple lane replacement, okay? And again, keep in mind, all of this work is being done at night. Okay, so just another look at what we are trying to do. So when we're doing the repairs, basically we are opening up the hole, taking out the damaged concrete or cracked concrete or whatever it may be, distressed concrete, preparing the base, installing dowel bars, and bringing the panel, fabricated panel at full strength, and placing it into the hole over the dowel bars. This is one concept with the dowel bar slats at the bottom, okay? In another concept, we have slots at the top. That also works. And then we come back and we grout the slot hole with the fast-setting patching material, and we also apply some bedding material, undersealing, so the panel is making full contact to the grade or the base.
Do you normally have a dowel on one end of the slab and then slots on the other? Or how does that
Okay,
work?
so in the repair application, we have dowel bars drilled and grouted on at each joint face. And you would have slots at both ends because we are just doing a single panel. When it's a continuous application, you will have the slot at one end and the dowel bar at the other end. We just set them next to each other. And I'll show you the schematic. So that's where it is. So this is the continuous application. We'll have a panel with dowel bar at one end and the slots at the other end. Okay, and we can have slots at the top or slots at the bottom here. So here there is a slots, and this one has dowel bars. Okay, and we would be patching or grouting the slots in a similar manner. Okay, so again, following up on these applications, for repair applications, we are basically using panels that are what we call normally reinforced. Okay, just some reinforcement. Anytime we have a panel, we are going to be lifting it up, 4-point lift. If we don't have reinforcement, what would happen? There is a possibility the stresses become high and we can have cracking. When it's full strength, maybe it's not an issue, but we are lifting this up the next day at 16 hours. So we place the concrete, and I'll show you details later on. So we are fabricating the panel. One evening, we are placing the concrete. The next noontime, we are stripping the forms, lifting. So within 16 hours, we expect about 2,500 PSI strength. But we still don't want to take a risk of something happening to the panel and panel coming crashing down on somebody. So panels are always reinforced. And as the panels get longer, or to save on reinforcement placement, the panels can also be pre-stressed, okay? The wider, the longer the panels get, the stresses become too high, and we do pre-tensioning at the plant. For continuous application, we have the same thing. We have jointed systems. These are individual panels that would be referred to as jointed systems, or we can have post-tension system. Again, jointed system, we have the same reinforcement in the panels or pre-stressing. For post-tension panels, what we are doing is we are getting a large number of panels together and then post-tensioning them at the site. So the panels are connected together. I'll show you the detail later on. And we can have a post-tension length of about 250 foot. Then an expansion joint and another 250 foot. So what does that do? It eliminates the intermediate joints. Okay, a lot of agencies don't like joints. So that's another approach to it. But it has not spread widely in use. So we have had few demonstration projects and one or two production projects, but it's much simpler to do the jointed system. So most of the projects now being constructed are based on the jointed system. So just a quick application before we get into some of the details. So we are doing slab replacement, okay, individual panels. So a few nights before, we would come in, make sockets, full depth sockets to isolate the repair area. We'll come in the night of the repair, starting at about 8 p.m., okay. Take out all concrete and prepare the base, drill the holes for the dowel bars, and get the base ready. And then bring in the panels. The dowel bars have been inserted, epoxy grouted. All of this is happening that first night, okay? The panel removal, the saw cutting is done a few nights before, but the panel removal, preparing the base, and installing the panel is done the first night. This is that one concept with dowel bars, slots at the bottom on both sides in this case, and then open to traffic the next morning. The next night we would come in and fill in the slot with the grout material, fast setting grout material. So it fills in the slot. And then we also do some undersealing under the panel. And we're back to operation. Now if the contractor has timed it well, this second night's operation could also be done the first night. Okay, so you don't have to come back. When we do this type of repairs, we can do about 20 repairs per night. They are spread out all over 2-3 miles, okay? This is the continuous application. This is the real project now, okay? In LA area, Los Angeles area, this is the primary technique used to rehab their pavement system, very old aging pavement system. Have you been to LA? How many of you have been to LA or seen the movies and whatever based in LA, okay? You know what the traffic issues are. I mean, most of the time it's a gridlock situation on the interstate system. So this is a project somewhere downtown LA area and lots of segments that needed work. So this is what it looks like, okay? This is a real project now. You got outside 2 lanes. You can see how damaged they are in each direction, okay? And they have not done much rehabilitation, or they've kept up with it. But now it's time to do something because the serviceability is very poor, heavy traffic. And on this type of roadways, they cannot even do work on weekday nights. They have to do the work on weekend nights, okay, because traffic is so high. So the idea is that every night that the lane is closed, you take out 600 to 900 foot length to remove all the concrete, replace the base, put in the panel, do all the grouting and everything all within that one night. By 5 o'clock, you are open to traffic, okay? So, and that's basically what we are trying to do. In most of the urban areas, this is a critical situation. So that's just to give you an example, quick, before we get into the details, just to basically whet your appetite, okay? So here it is. We start at about 8 p.m. or something, starting with the lane closures, and start removing the concrete. We are also removing, in this case, the base, which is a lean concrete base. That's what they use in California. And then prepare the base. All of this is being done like this would be at 10 o'clock at night. And then we put a lean concrete base, rapid setting lean concrete base. That's using a mobile mixer, about 4-5 inches thick. finish it up. As soon as it's slightly ready, it's slightly set, we start bringing the panels. Okay? So by the time the panels are ready to install, it's probably about midnight. So then we have 4 hours to install the panels. We are installing the panel, one panel every 6 minutes. So we're installing about 10 panels per hour. In 4 or 5 hours, we're installing 40 to 50 panels. In this case, this was like a 16-foot long panel, so we're installing about 900 foot of new pavement every night. Okay? So early in the morning, we are still finishing up the installation. Then we are doing some other activities. In this case, we are putting some bedding grout below the panel. We'll discuss that later on. And then by 5 o'clock or 5:30, we are open to traffic. We can't afford to delay it, okay? Because if you delay it with 100,000 vehicles per day on any of these segments, everybody's going to start making phone calls. Everybody has cell phones in their cars, okay? So even though they're not supposed to use. This is another example, a slightly different, unique example, rutted asphalt pavement. So this is a real section. It's a left turn, 2 lanes, left turn lanes. And this is going to a port facility in one of the southern states. So they keep fixing the asphalt every few months. The mill replace it, it keeps rotting, okay? That's how much rotting it does within 6 months. So they've decided to do precast pavement replacement. And this project coming up next year. But you can see in this 2-lane, in this case, they're going to put 2-lane wide panels, eliminating the center line joint. And hopefully all this work will be done over 2 nights. And you don't want to disrupt the what?
Why didn't they do the Los Angeles project like that? 2 lanes.
They can only, in there, they can only afford to close 1 lane, okay? And they have to maintain, the 1 lane is needed for bringing the panels. And then you need to have 1 or 2 lanes to carry the traffic. So most of these places, we are only doing 1 lane at a time. If you got multiple lanes, we have done some 2-lane wide projects also. But this is a unique, we got 2 extra lanes. As you can see, 2 extra lanes that could be used for the left turn traffic at nighttime. There will be less truck traffic at night, so it works out better. Okay, so now we are getting into some technical details. So we have the panel, very simple. Anybody can do it, okay? I can do it, a panel at home, okay? The difficulty is, what's the problem with the panel? Smooth face, okay? We connect panel to panel without any load transfer, what happens? We've got 0 load transfer. And we've got problems with deflections and faulting and so forth. So the first thing we have to do is provide load transfer, okay? Different schemes. We can, typically we are using a dowel bar retrofit concept. We have a slot and we have dowel bar. The slot can be at the top, slot can be at the bottom, as we saw in some of the slides presentation before. So the dowel load transfer is one thing. The other critical thing is how to place the panel, okay? We place the panel on the grade. We have to make sure the grade is very well finished. So that's one technique we refer to as grade place panels. A lot of people don't like that because it takes too much time trying to get the grade level, and we may have to use some poor material like bedding material to provide us that smoothness. So we don't like that technique as much. So the other technique is to bring the panel and put them on leveling lifts, okay, 4 leveling lifts. We leave a gap about 1/4 of an inch to 1/2 an inch. Then we don't have to worry about how well the base is finished, okay? We fill that gap with a fast-setting grout material, okay? So keep in mind, 2 placement techniques: place on the grade, and then place on a grout-supported system using leveling lifts. Okay, so I'll give you some examples now. So this is the grade-supported system. Okay, grade support. Whether it's a repair application or a continuous application, we prepare the base. We place the bedding material. In the old days, we were using loose bedding material, unstable. And sometimes it would get to be, instead of a 1/4 inch, it would get to be 1/2 inch or even an inch. So basically we're placing panel on a very unstable material. And that's what gives so if you step on it, you can see your footprints. So even on paper, we say it should be only 1/4 inch. In practice, it could end up being thicker. So now we are using cemented bedding layer, okay? That's much more stable. Using a ready-mix truck, bringing the cemented sand. And so that's the technique we are using for Great Place system. This is the grout-supported system. We have the panels, we use leveling lifts, and then leave a gap that 1/4 inch or 1/2 inch, fill it with the grout, fast-setting grout, and then remove the leveling bolts, and we're ready to open to traffic by 5 in the morning. The grout requires only an hour or so of set time to gain the strength needed to carry traffic. This is LaGuardia Airport. Early on, we did a project there, and that was a generic, using generic system leveling lift. We placed 4 plates for each panel, and then use the leveling bolts to adjust the grade. You can see a surveyor here making sure the plates were level at the right elevation. We don't use surveyors for highway applications. And so this is that second approach. And now we've got some pretty nifty gadgets to provide the leveling lift system that are built into the panel itself. So we don't have to go and put leveling the plates by hand. They're already built into the panel, and it saves us some time. Okay. This is just for the repair application. Again, we are just doing a panel at a time repair. We can use strong beams. There's another system where we bring in the panel, put it in the hole, and then apply polyurethane grout. So the panel is sitting about an inch below the final surface. The pump in polyurethane grout, it expands, raises the panel to the right elevation. Of course, we have to know how to do this, apply the proper grout material and so forth. And then you come back later on and cut slats to provide for the dowel bars. Okay? So now we'll talk about load transfer. As we discussed, there are 2 techniques, slats at the bottom. We're always using some sort of a load dowel bar retrofit technique. Okay? In the dowel bar retrofit technique, we go to existing pavement, which is exhibiting poor load transfer at joints. We cut slats, we put in the dowel bar in the slats, and we fill it with the fast-setting material. And we place about 4 dowel bars in each wheel path, and that should provide us the good load transfer. So we're using a scheme like that. So we have what we refer to as the bottom slat system. Okay, that's a proprietary system developed by the Fort Miller Company. And then we've got several versions of the top slat system. Okay, most of them are generic systems. And only one is the proprietary, and I'll give you an example of that, California developed system. So this is the bottom slat system. So whether you have dowel bars or tie bars, you can use it for both applications. So again, as we mentioned before, we can use it in a repair application with the dowel bar drill and grouted dowel bar and slats at the bottom, or we can use or for a continuous application where one side of the slab has dowel bars, the other side would have the slats. Okay, and then we come back and fill in the slats with the grout material, and that's what it would look like if you took a comb. Okay, sort of a wedge type shape. So the grout material, even if it doesn't bond to the concrete, cannot pop out. This is a top slat approach now. Since that other system was generic, many of the states don't like to use proprietary systems. So a generic system was developed. In this case, we have a narrow-mounted top slat because we don't want to, even if this is not grouted the same night, we don't want to have wider slats that would interfere with traffic operation, motorbikes, and so forth. So this is referred to as narrow-mounted slats. In this case, basically, our slat is the length of the dowel bar. So before the panel is installed, we put the whole dowel bar into the slat. And once the panel is placed, we have a hole in the existing pavement or another pavement, adjacent pavement, a new panel. And we basically come in and slide the dowel bar into the hole in the adjacent pavement, okay? And Illinois Tollway uses this system when they do repair and rehabilitation work. This is a modification of that system. Instead of having an open slot, again, we are hiding the whole dowel bar into the slot, that 18-inch or whatever length of the dowel bar is. But instead of having an open slot, as the Illinois system, here they have only a partially open slot at the back. So the idea is you have partially open at the back, you are basically going to push the dowel bar into the hole in the adjacent slab, whether it's a drilled hole for repair application or a precast hole in a new slab, continuous operation. And that's what it shows here. So the panels are placed, it is just pushing the dowel bar in there, they come back with the same repair material and fill in both sides. Okay, pretty efficient, it works. This is another variation of that same scheme. So instead of having that partially open, this is the modified version of the dowel slot system where we have dowel bars at one end and the slot at the other end. So in this system, basically we are placing this panel first, then bringing the next panel and sliding it into the slot. And this is also very efficient. We are placing about 50 panels per night with this system, 6 minutes per panel, okay? And that's a different variation. This is referred to as the teardrop slot design, and different contractors or precasters have come up with their own designs that work for them. But the idea is you have a narrow slot, it widens out, so it's a wedge. So whether it's a bottom slot or the top slot, you basically have a wedge type system. So you are not necessarily relying 100% on the bonding, but bonding is there too. This is the post-tension system. I'm just going to briefly describe the concept. So here we are bringing the panels, 20, 25 panels. They may be 10 foot long, but 12 foot wide or 2-lane wide, okay? So we're bringing 25 of them together, 20, 25 of them, depending on the length of each panel, and we get about 200 to 250 foot length. That's post-tension. Different schemes, we are post-tensioning them from the middle, from the ends, and the current version, we are leaving a gap, and as shown here, post-tensioning from this end to the other end, 250 foot away, or whatever that length might be. So what's the advantage of this? There are no intermediate joints. These are all very tight joints. And the disadvantage is we are left with an expansion joint, about 2-inch wide expansion joint. That may require some maintenance in future. What's the other big advantage of this? Where's our concrete expert? Okay. What's the other advantage of this system? When we post-tension, we are inducing about 150 to 200 psi additional compression. So what's our concrete flexible strength that we designed for? About 600 psi. And for 600 psi, let's say our design thickness might be about 10 inches, but by adding 150 to 200 psi additional strength, we can reduce our thickness. So when we do the post-tension system, that 10 or 11-inch jointed system, the comparable post-tension system would be about 8 or 9 inches. So we are reducing the cross-section, we are reducing concrete use, cement use, more sustainable, et cetera, et cetera. And this is very important because if you have an existing pavement where you're just replacing 1 or 2 lanes, and your existing cross-section is only 9 inches, but your new design for the next 40 years might require 12 or 13 inches, you can post-tension the panels and use that 9 inches to give you that same long-term service life without having to change the cross-section. Okay, so just for those who are techie people, some numbers. So we are using strands, 0.6 diameter strands, typically 80% ultimate load. So when we post-tension it, we are applying about 46,000 pound force. And that's sort of safety issue, because if you don't have good anchorage, this whole thing can spring out of the ductwork, okay? And we have seen tendons doing that. They just get out like a spear. And if you are hanging nearby, boy, that wouldn't be nice to do. The pre-tensioning, when we do the pre-tensioning at the plant, typically we are using only 1/2 inch diameter strand, and just to have it be more efficient in terms of fabrication, because then we don't have to use reinforcement. So this is some examples of the post-tension system, typically referred to as the PPCP. So you can have, these are 10-foot long panels. You can have keyways that provide the connectivity and some joint load transfer. You can have different cross-section in your precasting, okay? So built-in cross-section, and just different ways of providing the tendons. This is a tendon that's post-tension later on, once it's throughout the length. This is a California project. They actually had a 36-foot long panel. So instead of the 10-foot panels like here, requiring 25 placement to get 250 foot, they decided to go with 36-foot long panels. So now you have reduced the number of panels required. You've made it more efficient, because every panel that is placed requires so much time, okay? So just quick comparison between the precast jointed and precast pre-stress. As I mentioned before, the conventional could be 10 to 14 inches depending on truck traffic. With the precast pre-stress, you can use 8 to 10 inch thick panels only. Joint spacing 50 foot typical, here 150 or 200 to 250 foot. The difference is expansion joint is needed, okay? Typically we have to leave some gap when we place panels, because we can't place panel in a very tight space. So for the jointed system, we are leaving about quarter inch to up to 1/2 inch maybe sometimes. For the precast pre-stress, we got longer post-tension sections, about 200 foot, 250 foot. So there's more expansion contraction taking place. So you have to go up to 2 inches in our expansion joints. Okay, very quickly, technical considerations, okay? So typically we talk about general details, concrete requirements, jointing, load transfer, support conditions. Some we have already discussed, and the surface characteristics. So we have different systems now that have been developed and being used, and most of them have very common features. The general details are very similar, concrete requirements are similar, but this is where many of the systems differ, are different, okay? How they provide load transfer, bottom slat or top slat, how they provide support condition directly on the grade or the gap supported, okay, grout supported system. And the other thing that I just want to point out is, once installed, this precast panels behave just like any other jointed pavement, okay? The advantage here is that the precast panels are reinforced or pre-stressed. So if a crack develops within the panel, it's going to be held very tight. There's a higher amount of reinforcement we use, and so we are not going to see any distress, significant distress in future at these crack locations, okay? Okay, so this is basically what our expectations are from the precast concrete pavement. Very similar to newly constructed pavement or new design. We are looking at for repair application at least 15 to 20 years instead of going back every few years. Okay, we are not doing fix the fix anymore. For continuous applications where we are doing miles and miles of this, we are looking at service life of 40 years. Again, not 2 or 3 years, and then coming back with some other treatment. Pavement failure would be a result of traffic loading. That's what we design our pavements for. We don't design it for some screw up by the contractor or because somebody used bad material or bad concrete, okay? So we shouldn't have any failure from any other reason than what we are designing for, that is millions and millions of truck load applications. And so the pavement will maintain desirable ride and surface texture characteristics with minimal intervention, because this is a high volume situation, roadways. we can't afford to go back and keep fixing the pavement. So the only time we would have to do it is to correct for ride and texture, maybe every 15, 20 years or so. Okay, and these are not significant repair that doesn't require too much lane closure and so forth. So keep in mind the lane closure and the extent of lane closure is the key item here. We are trying to eliminate or mitigate. Again, very quickly, for those who like numbers, if you have a 12 by 15 panels, that's very commonly used. 10-inch panel, the weight is about 21,000 pounds. Okay. The 12 by 36 foot panel that I was showing you before, if it was 10-inch thick, that's about 50,000 to 60,000, depending on the thickness. So it requires a lot of good-sized crane for most of this work to be positioned at the site. Also, I mentioned before that if you are casting the panel, the next morning we are stripping the forms and then lifting it, it develops some stresses because of the weight of the concrete itself. When it's a small size panel, that's a any of this 10-foot length, 12-foot wide, and so forth, 12 by 12 or 15 by 12, the stress that's developed, the tensile stress that's developed is very minimal. Okay? So within one day, the concrete strength can accommodate it. But we still provide reinforcement because we don't want to take chances. Once you go in the length or the width, our stresses become high. So at 24 or 16 hours when strip the form and we are lifting it, if it's a long panel, the stresses are high, and we have to make sure the panels are pre-tensioned at the plant. Okay, so panel handling, as I mentioned, it's a four symmetrically offset locations. The inserts are located, and they're built into the panel itself. And as you can see, 1, 2, 3, 4 panels properly aligned, so it minimizes the stress development. This is at 16 hours. Okay, the stripping is done. So the panel has to have sufficient strength to be able to be lifted and then moved. This is the 36-foot panel. So you can see there the stresses would be much higher, and these panels were pre-tensioned at the plant. Okay, some other details, technical details. We talk about the load transfer at the joint. In the past, we used to talk about in terms of the load transfer efficiency. How many of you have done deflection testing, FWD testing? Few of you. Okay. So basically at the joint, we are looking at how well the dowel bars are transferring the load. Okay. If it's 0%, that means there is no dowel bar action taking place. Okay. Maybe we don't have any dowel bars. So if you place panel to panel, smooth face, there is no load transfer, it's zero load transfer efficiency. When we put the dowel bar in new construction, we get typically 95 to almost 100% load transfer. That means when you place a load here, it's transferred the load to the other panel. Both of them are helping carry the load. If there is no load transfer, only one panel is carrying the load, or one side of the joint, whether it's new pavement or precast pavement. Okay, and so that's basically what this figure shows. And what this other sketch shows that the load transfer carried, what's the axle load? Who plays around with equivalent axle load or truck axle load? What's an axle load on a truck? What's the legal limit? Keep it simple, 20,000 pounds. Okay, single axle load. When the axle load is at the joint, how much do you expect it to transfer to the other side? If everything, life is nice and so forth, 100%, 50% of it. Then one slab has 10,000, the other slab has 10,000 pounds transferred across. So it's the dowel bars that are transferring across the 10,000 pounds. But we have two wheel sets. So each wheel set is transferring 5,000 pounds across. Okay? Everybody get that concept? So the dowel bar at the lane edge is transferring 3,000 pounds. If the truck is following the lane edge, it's carrying 3,000 pounds. And all the other dowel bars are carrying 1,000 or 500 or so. So we are typically designing for the most outside dowel bars. If your lane is wider, sometimes we use widened lane, then the most critical dowel bar is carrying only 1,000 pounds because it's much more distributed across the 4 or 5 dowel bars. So keep in mind that we are transferring 5,000 pounds at each wheel set, and the critical dowel bar is carrying maybe 3,000 pounds. What's 3,000 pounds? I always like to use this example. 10 of your offensive line guys, football team, 330 pounds, you put 10 of them on top of each other, that's 3,000 pounds. And then how much truck traffic are we talking about over 40 years? 100 million, 200 million. That means those 10 guys jumping on a dowel bar 50 million, 100 million times. That's what you're asking the dowel bar to do, okay? And so we have to make sure the dowel bar, at least in the precast, is very robust, the design, the slot design, the material we use, and so forth. I mean, one-time testing, we apply a drop, one time, one truck pass, it's not a problem. But we are always designing for this 30 or 40 years, 100 million trucks. So we can't afford to have marginal construction taking place. I'm just going to skip because of the time. So panel support condition, so when we are doing some rehabilitation work, typically we're just taking out the concrete or the asphalt surface. We are going to, if it's a granular base, we may just rework, compact it, and regrade it, and sometimes use a bedding material. If it's stabilized, if it's a cement-treated base, but the problem is in the concrete, we take out the concrete, then trim the cement-treated base to make sure we have got proper thickness for the panel. We don't want to bring the panel and find maybe the concrete was shy at that location and the panel stands up half an inch or 1 inch. Because that happened in our early projects, okay? We didn't do enough coring to determine what the existing pavement thickness was, and we bring in the panels and they're sticking out. Keep in mind at 5 o'clock in the morning, we have to open to traffic, okay? You can't have one lane sticking up compared to the adjacent lanes. So now we typically recommend the trimming, and then sometimes we apply the bedding material. And the bedding material is what I said before, it's a fine-grained cemented material or thicker layer of rapid setting grout if you are using the leveling lift system, okay? In California, whenever they do this rehab, they're looking at the 40-year life, they take out the existing base and put in a new, what they call rapid setting lean concrete base. And again, this is all possible during that one night of lane closure. So quickly, pavement design consideration. For repair application, keep in mind, we are going to go in and cut out the hole, okay? Longitudinal joint here, longitudinal joint here, and we're going to make transverse cuts. We bring in a panel, there is no way we can bring in a panel and try to place it in a hole that's precisely the size of the panel. That's just physically impossible. So we bring in a panel that's perfectly dimensioned. That's a 12 by 12. The tolerance may be an 1/8 of an inch. We cut a hole. Some guy cutting a hole, I shouldn't say some guy, a saw cutting crew cutting a hole. Okay, they're following the existing longitudinal joint that was cut in a new concrete long time ago, 40 years ago. We don't know how straight it would be, okay? And then we are making a transverse cut at night, maybe using laser, as Marshall likes to say, we measure with a micrometer and then come back and cut a saw cut that's 1/4 inch wide, you know? So even if you precisely measure it, the saw cutting guys are not going to be that precise. So when we put a panel in, we are always going to deal with some gaps, okay? Typically we say not more than 1/2 inch. We can't control the longitudinal joint as much because we are cutting it with whatever joint was there or joints were there during construction, original construction. This could be 12 foot, or it could be 11 foot and 11.5 inches. So anyway, we are leaving some gap here. That's by design, okay? And in the continuous application now, we don't have to worry about the saw cut here. We're taking out about, let's say, 600 to 900 foot, and we can bring the next panel next to the previously placed panel. We can control the joint width, let's say 1/4 of an inch. But we can't control what happens to the longitudinal joint. We may end up with a 1/4 inch, 1/2 inch, or even 1 inch many times. So that was the dimension. So panel thickness for the repair applications, we are basically putting the panel to replace an existing panel. So whatever the slab thickness was there, we are using the panel with that thickness. Okay. For continuous application, basically we are doing a typical pavement design, and whatever is required. It's 8 inches, 9 inches, 10 inches, or 12 inches, depending on the truck traffic. So typically, our thicknesses tend to be 10 to 14 inches for jointed system. If it was a post-tension system, it would be less by 2 to 4 inches. Okay. Concrete strength, typically very similar to what we typically specify for cast-in-place or new concrete pavements. 650 psi, but keep in mind, as I mentioned before, we are stripping the forms at the plant at 16 hours. So we are going to require, or the contractor or precaster will use a slightly higher strength, so they can achieve that 2500 psi within 16 hours. So by nature of that, we get slightly higher strength in our concrete. Joint design, again, for repairs, it is whatever it is. The slab dimension, we are just replacing that. Or if it's a joint, we may cut out about 6 foot or 8 foot. If it's a crack, again, it would depend on the condition of the panel. For continuous repair, basically, we're using the 15-foot joint spacing on most of the projects, 15 to 16 foot. Some contractor might say, well, I can speed up my production if I go 16 or 18 foot. There's nothing wrong with that, okay? So again, load transfer, we talked about typically 1 1/4 inch, 12-inch center, but we are using just 4 and 4 on most of the projects. We don't need continuous spacing of the dowel bars, 11 or 12 per joint. And 14-inch dowel bars, we know exactly where the dowel bars are going to be placed. For cast in place, we use 18-inch dowel bars, and typically we need about 7 inch of the dowel bar on each side of the concrete. So we typically say 7 and 7 is 14. So we are giving the contractor about 4 inches to make a mistake where they cut the joint, okay? But as long as we get 7-inch embedment, we're okay. For the precast, we know exactly where the joint is. So there's no point in using that 18-inch long bar. We just need 7, so 7, we just use 14 inches. Reinforcement, again, I mentioned we're using it primarily for the lifting and shipping, and that's what it would look like, typically 2 layers of the steel, or you can have it pre-stressed also. Okay. Very quickly, panel fabrication. So we can do panels in a plant, precast plant. Okay. So in precast plant, they have a bay. They can put in only so many forms. So typically 6 to 8 panels per day. So they have forms for about 6 to 8 panels. Okay, so every day they are doing 6 to 8 panels. Normal concrete strength testing, they're using mix, workable mix, about 6-inch slump, and consolidating it, finishing whatever tining is required. Okay, and then 16 hours stripping the forms, lifting it out, and then whatever curing, finishing operations. So that's the reinforced. This is the pre-tension panels now being fabricated. So here, the precaster may have this long beds, okay, 300 foot plus long beds. So they can actually fabricate about 15 to plus or minus panels per night or per day. Okay. The advantage here is he doesn't have to do the reinforcement. See, all this reinforcement, that requires a lot of labor. Okay? In this case, pre-stressed panels is just threading a set of tendons from one end to the other end. So many tendons, let's say 6 or 7 tendons, maybe 6 tendons for a 12-foot wide panel. But he just requires, he just puts 6 tendons all the way through. It takes care of all the panels, 16 panels. The priest jack up the load, pour in the concrete. I mean, they're still doing some other work for all the ports, grout ports, and so forth. This is that leveling lift system. So they still have to do all that positioning. But they save a lot of time not having to do the reinforcement. And then they come in, place the concrete, and then come back and cut out the tendons at every of this location. Basically cut and burn out the tendons. Okay, and sometimes they also do steam curing to accelerate the strength so they can lift the panels the next day since this is being cured outside. And once the panels are fabricated, the finishing operation taken to the storage site and then cured for about 7 to 14 days before being shipped to the site. So we've got projects using 2,000 panels. There's one project under construction in LA area, 7,000 panels. If we are fabricating 15 panels per night, you know how many days it would take? Okay. So basically on many of these projects, we have to do several weeks or months of backlog of panels. So we have to prepare the hundreds of panels beforehand, because once we get to the site, we are chewing up all these panels, 40, 50 panels per night. So when we are doing repairs, we can do 15 to 20 repairs, continuous, jointed. We are doing 40, 50 panels per night. Depending on the panel length, we can do up to 900,000 foot. Long time ago, I set a goal that if we can do 1,000 foot per night, we would be doing pretty good. We are already meeting that length, okay? If we have 2 crews working side by side, we can double it. So, quickly, panel installation. So a lot of items we have to take care of. Now we are at the site. We've got the panels fabricated. We're at the site. Of course, we have to do maintenance of traffic, on-site equipment management, et cetera, emergency management. Okay, I'm going to hurry up. So I'm going to just go and give you some examples of installation. We are taking out the concrete. Under traffic, there's a truck passing by, so 1 or 2 lanes are open to traffic. One end we are working on, another lane we are bringing in the material, okay? So in this project, they had a cement-treated base. They decided to leave it in place, so they're trimming it, placing some bedding material, roller compacting the bedding material. In a longer hole, you can afford to do that. If you are doing a single panel, you can't bring in a roller, you are using a plate compactor. And then bringing the panel and opening to traffic by 5 in the morning. As you can see, heavy traffic already, okay? So you can't afford to delay it. This is another example, an asphalt intersection. You are taking out the asphalt, bringing new material, new base, and then finishing the base, bringing the panels, and open to traffic the next morning. Okay. We have done some testing to evaluate the performance. As you can see, very good deflection response, okay, good load transfer, and we haven't seen any serious issues with performance for projects that have been in place for 10 to 15 years now. So summarizing, this is a new technology in place for about 15 years. But we know that well-designed, well-constructed systems can be installed rapidly, can be expected to provide long-term service, room for new systems, refinements to continue to improve the efficiency. And the important thing is contractors who have not had prior experience with it are able to perform this work. Okay? And I'll take some questions, I guess. Yeah. Sorry, that took a little bit more time.
Any questions? Shiraz, thank you.
Yes.
What is the relative cost of performing that work in a short span of time?
Okay, so I'm glad you asked. I forgot to mention it. So when in 2001, when we were just doing the first few projects, it was about $900 per square yard. Compared to the so-called record-setting repairs, That was about $200, $250 per square yard. Now, this is costing us about $300 to $400 per square yard, depending on the number of panels involved and so forth. The rapid setting has come up. That's costing us about $300 to $350 per square yard. So there is some difference. But when you consider the long-term risk of one material versus the precast stands out looks much better. Yes, Marshall?
How's the performance of those bedding materials doing? Over the years, we've always had trouble with grouted, joints and stuff like that.
So in the earlier, we were using that sand bedding material. In many of the projects, they exhibited some cracking in the panels. There may have been other reasons too, but it's just that the bedding material is not stable. It could wash away, etc. Now we are using the cemented bedding material for the grade place system. There shouldn't be any issues. With the grout place system, the high strength bedding material, they've been in place for about, let's say, 3 years, and we haven't really seen any issues. Yeah. I mean, we have had some initial failures and so forth, or poor construction, but once you take out the reasons for that, this system is here to stay.
You're saying you put the bedding material as cement now?
For the grade place system. Okay, that's my recommendation.
Supplying sand with cement added?
Yeah.
So it's bordered.
No. Yeah, there is some body to it. But the grout place system are basically mortars. Yeah.
Any other questions?
In a region where good weather is anticipated normally over long periods, and if the saw cutting is optimized at a particular time, why would precast panels be better than fast setting concretes?
No, the fast setting, the problem, it's a risk issue, because when we get good projects, we really get good projects. It's just that when the fast setting trucks come in, they're all backed up in the same congestion, because we have shut down 2 lanes, and the trucks coming in from the ready-mix plant, they get stuck in traffic, they come late, maybe sometimes some water is added to give it more workability and so forth. So we are not consistently getting good quality. If you can control it, but the cost is again coming up to the level, the precast cost is going down, the fast setting cost is going up. So the difference is not much. So, yeah.
I have 2 quick questions. So when we go to the long slabs, is shrinkage cracking a problem? That's the first one.
No, because they're all cured at the plant.
So that's
In a
no
free
problem
condition.
whatsoever.
Yeah.
Excellent. My other question is rocking of the small slab an issue? Because that depends how well you are preparing the platform, and that's going to be affecting the alignment.
Sure. So if you have that loose
Yeah.
bedding material, that could be an issue in the future.
Okay.
But the load transfer is so good that it almost works as a bridge. Okay, and the panels are reinforced. So even if they crack their loads, it's not going anywhere.
Yeah.
Yeah.
Okay.
But we are trying to keep people away from using that loose granular material.
Right.
But just as a final, we started using it. We did some initial work in the 70s, putting precast panels here and there. Technology was not right. We gave it up. Russia has been using our Soviet Union in the 50s. They would ship panels by train to Siberia because they had a very small construction season, and there were thousands of miles of precast pavement. And even in airfield applications, they've been using precast, and in Japan too, they've used it since about 1960s, but not at the scale that we are looking at right now in the US.
Any other questions? Shiraz, thank you so much again.
No, I appreciate the
Jose and his students going to be hosting you to talk